Hey, physics awesomes, Mr. Johansson here. We're going to go over inelastic collisions. Inelastic collisions. So in an inelastic collision, two objects collide and stick together. Now, if you think about that, you're driving a little, I don't know, a tiny little car and you hit a Mack truck. Bam! Okay? You're stuck into the Mack truck. Do you stop the Mack truck? No, you don't. Do you slow the Mack truck down a little bit? Yes, you do. Okay? So these are inelastic collisions. And do you use up a good deal of the energy that you had just squishing yourself into the Mack truck? Yes, you do. I would suggest you avoid Mack trucks, by the way. They're probably not good for you. But let's check out an inelastic collision. I have one set up here. So here I have a 5 kilogram object. It's moving at 4 meters per second. You'll see on top, this is the momentum of it. 20 kilogram meters per second to the right. Over here, I have a 15 kilogram object. It's moving to the left at 4 meters per second, giving a total momentum of 60 kilogram meters per second. So when they collide, well, what's the mass now going to be? Excellent. 20 kilograms. Well, what's the momentum going to be? And here you add the momenta together. Consider their vectors. So this is positive, that's negative. So you can have 20 kilogram meters per second plus negative 60 kilogram meters per second. Well, that's all going to equal negative 40 kilogram meters per second. That's the momentum, and if it's negative, that means it's going that way. And I'm going to remove the negative just so I have 40 kilogram meters per second going to the left. What would the velocity need to be of a 20 kilogram object to carry 40 kilogram meters per second? And again, you can see they're set up perfectly. So to get rid of the kilograms, you just divide and simply 2 meters per second. That is an inelastic collision. Those two objects have collided, stuck together, used up a lot of their energies of motion to stick together. There's a lot of heat coming off that, all the energy being dissipated. Bottom line, their masses are added together. Their momenta are added together. So masses come down here, momenta comes up here. Do the division, you got your velocity there. All right? Not so bad. So that's an inelastic collision. Next time we're going to do pin equals pout. See how you like that one. See ya.